Okay, in this question here, we're going to write it as a single log. State any restrictions. I'm going to state my restrictions right away because I don't want to forget about them, and you want to state them as the original restriction. So in the first one, can't take the log of a negative number. X plus 3 has to be greater than 0, which means x is greater than negative 3. In the next one, x squared plus x minus 6 has to be greater than 0. Now, we can factor this, but I want you to remember from 20-1, we never solve quadratic inequalities algebraically. We always look at the graph. So I know that factors as x plus 3, x minus 2. So I want to look at the graph of it, just drawing a little sketch. I know that I have an x-intercept at negative 3, an x-intercept at positive 2, and the graph opens up. So it doesn't really even matter what it looks like. I just want the x-intercepts in the direction of the opening. So I can see that I have two areas of restriction. Here, x has to be greater than 2 to the right of 2. Here, x has to be less than negative 3. So that's for the quadratic. So I want to choose the restriction that kind of covers everything. Okay, so the first restriction was that x was greater than 3, negative 3, so it was like everywhere here onwards. This restriction was it could be either ends of the graph. But if it was the left end, it wouldn't satisfy the first log restriction. So what I want to do is go with the bigger of the two that covers everything, which is x greater than 2. Because if I say that x is greater than 2, it satisfies this, that x is greater than negative 3, and it also satisfies the other one. It doesn't satisfy the other one, but this one and this one are in direct conflict with one another. So the overall restriction that satisfies the entire expression is that x is greater than 2. Okay, so now let's write this as a single log. So any numbers that are in front, I write them up top as exponents. So this would be x plus 3 cubed, log base 8 of x squared plus x minus 6. Now logs that are subtracted because they have the same base can be combined as one big thing by dividing the arguments. Now I already know how it factors because I did factor it for the restriction. I am not going to expand the top or the bottom because factored form is the preferred form, but I do notice using law of quotients, quotient law here, that I can keep the base the same and subtract the exponents. So I actually notice here this is supposed to be a 3, not a 2. So the 3 comes up top. This is a 3, not a 2 exponent, my bad. Okay, so to simplify this, it will be log base 8 of x plus 3. I have 3 on top, 1 on bottom. 3 take away 1 is 2, and x minus 2 on the bottom. And I'll just add on my restriction that x has to be greater than 2. So this, with the restriction, would be your final answer.